Go. Hello. Hello, Mr. Aaron, Mr. Ryan, are you right?
Yeah.
Okay, so yesterday we talked about the bubble sorting, which is a simple sort, right? Bubble sorting. And we also talked about not non-simple sorting, which is what kind of non-simple sorting we have learned in the past. The one with the O and
Quick
again.
sort.
Yeah. Well done. Quick sort and another one.
Bubble sort.
Bubble sort is a simple sorting. You know, if there are numbers and we have split it and then merge it together, what do we call it?
Merge sort.
Yeah, merge sort. And with the bubble sorting, so let's say 3, 2, 5, 4, 1. Okay, so every time we start a round of sorting, we swap the two numbers if this number is bigger than the last one, right? So look, 3 and 2. 3 is bigger than 2, so we swap it. So we actually, when we perform this one round of swapping, we always move the largest number to the end, right? So basically, we have an array. We have divided into two halves. The left subarray, left subarray is the one which is unsorted, yeah. And then the one on the right is sorted. So every time we do this bubble sorting, we move the one from the unsorted to the sorted one, right? Make sense? Okay, so today we talk about another sorting algorithm, which is also simple sorting algorithm, which is called the selection sort. Selection sort. Yeah? What's selection? Selection. Okay? Selection sort. It means that, okay, so we have an array like 3, 2, 5, 4, 1, 7, right? Okay, so now if we divide this array into two subarrays, the left one is the one which is sorted, and then the right is the unsorted. Okay, it's slightly different than the bubble sorting. Bubble sorting is the opposite. The left is unsorted. We bubble it out and move the largest one to the end. Let's sort it in the sorted area. But the selection sort is the left subarray is sorted. The right subarray, there's a partition here, is unsorted. So look, so every time I pick from here, which number is the smallest? 3, 2, 5, 4, 1, 7. Which number is the smallest?
1.
1. Then, okay, I select this 1, right? And I swap it with this and here, right? So what happens? So this becomes 3, this becomes 1. Right? Right? And now, for the sorted, we have one element. Let's move to here. From 2 to 7, which is the smallest? Which one is the smallest?
2.
Okay, then 2 swap it with itself, right? Okay, so then I need to move another one to left. 5, 4, 3, 7. Which one is the smallest?
3.
So what should we do with the 3?
Put it with move it with a 5.
Yeah, swap with 5. So look, 5, 3. Yeah, and then now we have one more element in the sorted, so I move it here. So 4, 5, 7. Which is the smallest?
4.
So what do we do with the 4?
Move it.
We swap with itself, so it doesn't move, okay? And then 5 and 7. Okay, 5 is the smallest. You get it? Make sense? Let's do another example, okay? So you know and understand. This is very easy. Yeah? Simple sorting algorithm is very, very easy, right? Look, bubble sorting, right? Look, right? Bubble sorting. Yeah, you blow a bubble, boo, 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 and the bigger bubble will be moving to the end, right? So we have an array. So the right hand side, this part, the right, yeah, is the one already sorted with the bubble sorting. Yeah, you always bubble up a largest element and bubble it up. Yeah, swapping. But with the selection sort, it's the opposite. The area. Yeah, this is sorted, and then here is unsorted. Yeah. So every time we perform a selection sort, we have one more element, right, selected from the unsorted area. So we have increased the sorted subarray with one element, and we have decremented the unsorted subarray with one element less. Make sense? Okay, let's do one more example. 5, 4, 7, 6, 2, 1. So what should we do
1
now?
is the smallest.
Okay, so
Swap
now,
it with 5.
yeah, we're done.
Yeah.
Okay, and then
you
now,
2 swap with a 4.
yeah.
And 4 swap with a 7. Yeah. And 5 swap with
6.
6.
Yeah. Okay.
And 7 swap with 6.
Wow, you got it pretty quickly. Yeah, that's it. Yeah, that's the diagram. Let's write it. And you need to think about what's the time complexity, alright? You need to think about the time complexity. Define, let's call it selection sort numbers. So now we want to call this n equal the number of elements, nums. Right? So now I need to go through this for I in range n, right? Right? And then for now the mean index, let's say the mean index is I, right? Mean index is I, and then I need to go through for j in range I plus 1 to n. If numbers j, yeah, look, this is index. Number j smaller than nums, mean index, yeah, mean index. Then I need to do what? I need to remember it. So the mean index will be equals j, okay? And then, alright? And then now at this one, I just need to swap the mean index with what? With I, right? Because I want to put it in the I, right? So how do we swap two values, A and B? How do we swap two values, A and B?
AB equals BA.
Yes, A, B. Or we can use another variable T, right? T equals A equals B equals T. This is also okay, yeah?
Mm-hmm.
Okay, so now I need to swap the index and mean index and I. Okay. So what? Nums j. I want to swap the nums I with nums and mean index, right? Mean index.
Min.
And then I just swap it wrong, right? Nums mean index, yeah? And nums I, right? Yeah? Look, it's so easy, right? Do you get it? This one? Yeah? Look. I need to look for every round I select, I choose the mean index, right? So if you look, the mean index will be I want to swap the minimum element, right? Smallest element. I choose the smallest element and I swap with I index, the index, the I's element, right? The element I. So for j equals range. So look, it's easier. Let's look at these numbers. It will be easier. 1, okay? Look, at the beginning, I is here, right? Look, I is here. So I is here, and then at the beginning, the mean index, I set it to I, right? I'm not sure because I'm looking at from I to this range, picking the smallest. So which is 1, right? J in range I, so J will be here to the range I, and I'll pick the smallest element, which is 1. Right? Look. And I swap this element with the 1 and I, right? So because mean index will be this one. The mean index will be pointing to the I, right? So I swap it. If nums J smaller than nums mean index, at the beginning, we are setting the mean index to the I, and then we use the elements on the right compared to itself, okay? If it's smaller, then I update the mean index. And if I go to the wrong, what's the mean index? What's the mean index? 0, 1, 2, 3, 4. Yeah, mean index will be 4. And then here, I will just swap with 4. Nums I and nums mean index. I'll just swap these two variables, okay? Well, what's the time complexity? Look, what's the time complexity? Alright, what's the time complexity?
N square.
Well done, O(n) squared. Because we have a for loop, we have another for loop, okay? So, remember, with the bubble sorting, we can use the variable swap. If no two elements, right? If the array is already sorted, then we don't swap, we don't continue, right? So in the best cases, when the array is already sorted, the bubble sorting is the time complexity is O(n), right? We know that. We talked about that yesterday. But for this one, this is always O(n) squared, right? Because there's no such things to check. If array is already sorted, it's still the time complexity is still O(n) squared. Am I right? Yeah.
I'm gonna check it again.
Because they look, if the array is already sorted, you still need to perform this, right? There's no such thing as checking, right? If the array is sorted and no swap. But the good thing about this algorithm, about the selection sort, is that how many swaps does it perform? How many swaps does it perform? And well done. That's a good catch. No matter how complicated is the array, it always performs at most n swap. But for the bubble sorting, you never know, right? You always swap. That will be n squared. Yeah. In the worst cases, look. In the worst cases, 4, 3, 2, how many swap? Look, 1 swap, 2 swap, 3 swap, 4 swap, and you put it at the end, right? And then again, 1, 2, 3, 4, yeah? Yeah? Alright? So you perform a lot more swaps than here. But for this one, we always have this n swap. But for the bubble sorting, the swap could be O(n) squared, right? It's actually n times n minus 1 divided by 2 or whatever, yeah? But for let's do this selection sort. 5, 4, 3, 2, 1. Okay, so how many swaps do we have? Look, we always pick them. Look, right? We pick the smallest, which is 1, right? Yeah? We swap it. 1 swap, okay? I have 1 swap, okay? Which is the smallest?
2.
2, I swap it.
3.
Okay.
4 and 5.
3, I don't swap. 4, I don't swap, yeah? 5, I don't swap, okay? So look, at most 2 swaps, okay? At most 2 swaps. No, now we're doing 2 swaps. But look, this one, you can say it's exactly O(n) swap. Why is that? Because if I equals mean index, you swap an element with Excel. Does it count as swap? If you count this swap, it's O(n) swap. If you don't count this swap like this, right? You always look. I'm here. I'm picking the small element, which is 3. I swap the 3 with itself. Does that count as swap?
No.
Okay, no, yeah, but yeah, maybe sometimes. Look, because both are okay. Yeah. If you counted the swap, that's okay because what? Look, these still gets executed if I equals mean index, right? So it swap with itself. But if you count it as not swap, then we have to do this. Look, if I not equals mean index, right? Then we can avoid swapping itself. Okay, so the number of swaps at most is O(n), is n swap, right? That's the advantage of the selection sort, because there will be no more than n swaps. But for the bubble sorting, this could be in a scale of O(n) squared, right? Because the swapping will be a lot more. Every time you do the bubbling, you always
14 minutes.
look. You always only move one element. You don't change the order of others. So you will keep swapping. The swapping will be more than the selection sort. But what's the advantage of the bubble sorting compared to selection sort?
Bubble sorting is technically the opposite of selection sort is putting the minimum on the front, but bubble sort is putting the biggest number at the back.
Well done. And in what cases, when the array is what, then the bubble sorting is better, is quicker. when the array is already what?
Sorted.
Yeah, when the array is already sorted, the improved bubble sorting, the first one checks there's no more swapping. So yeah, I think the array is already sorted, then I quit. So that will be just on, right? But the selection sort still needs to perform these, 2 loops on squared. But in what cases, look, if the swapping is very expensive, okay? Look, if it's swapping 2 elements is very expensive, then which algorithm is better? Selection sort or bubble sorting?
Selection sort.
Well done. Okay, that's it for today. Good job. Good job. Bye bye.